to our webinar for today. We've got Jay van Zyl running the session from Ecosystem.AI. We have been in quite a lot of really interesting discussions quite recently around AI agents. And so today is talking about our Ecogentic approach and the framework and everything that goes with that. Yeah, just so everybody knows, obviously this session is being recorded and you will have access to it on our YouTube next week. I'll send out links to everyone online. Welcome, Jay, over to you.
Thank you, Jess, for the introduction. We've got a fair amount of material to cover today, so I'll start with an introduction to give the last few people some time to join. Ecosystem.AI is a real-time behavioral prediction specialist company. We deal with various use cases across disciplines that we call, or we group into making money. So that means recommenders, customer engagement, interaction sciences, saving money. That means auto-escalation and business process automation and RPA inside a company for those who want to deal with process escalation and dealing with anything that's got to do with saving money. Protecting money is a special class of interest in our business, and that's all of our fraud, abuse, and special investigation work, including forensics and the like that we get involved in from time to time. So today, the primary conversation is about agentic frameworks and AI agent architectures that exist across various disciplines. The approach is to give you a high-level overview of some of the key concepts I covered last week. This week, we're going to get into a next layer of detail. I will also talk about a number of different architectures that have emerged out of various kind of platforms that are now being deployed into companies to ensure they can implement this concept reliably. And the basis of this is that there are just too many options for you to even consider evaluating every possible architecture, every possible technological solution. So we have decided just to select a handful for today's conversation. Obviously, the discipline, like we discussed last week, is way bigger than just the few frameworks that we're going to be presenting today. So the basis is that if you think about an agent-based architecture, you want to know what would the criteria be when you want to design something that's going to be, competing in the context of this broader market, as well as a part of a framework that can give you longevity. And at Ecosystem, what we've been focusing on from an R&D point of view is, can we find algorithms and methods that can get our clients to implement these frameworks consistently and reliably and make sure that they work in a way that they're supposed to. So let's just start with a quick perspective on where we see this going. The first thing is you have to understand some of the basic definitions. When you view the content afterwards, you can go and look at some of the detail of how these definitions are emerging. But the basis of it is that we are in a journey to automate work, and we're using models that need to reason to automate work. Historically, workflow or any of these journeys designed by classical systems required an enormous amount of thinking to reconfigure how you want to get some kind of specific outcome. The way we're seeing it now is that you want an ecogentic framework. You want an ability to bring an ecosystem of technologies and capabilities into the way in which you need to achieve an outcome. And if that outcome is, I want a customer to sign up for a service, I want to get somebody to onboard themselves, or I want to get an employee to decide when an escalation is due, or any one of these series of actions that must be performed, you want to have some kind of automated capability that can do that for you. Now, the way that the architectures have evolved over the last many years, we first had this predictive machine learning capability. That means text completion, text classification, sentiment analysis, all the capabilities that were used, especially in the last 10 years or so, leading up to about 2018, 19, post the early inventions of how transformers are going to be used inside natural language processing related activity. We found that you have to spend a lot of time training your own models, and a lot of those models are still very active and very useful. We use a number of our predictive machine learning NLP models that were trained on determining if a person's Myers-Briggs personality or their big five personalities of a certain type, because it's highly specialized, focused on solving a particular problem. And that meant we used to work on enormous data sets, train models ourselves that used to take a long time. What Generative brought for us is essentially a series of capabilities where these common models have been trained on enormous data sets at enormous cost, and you're not guided to produce certain outputs for you. So that means that the ability to have language comprehension, rather than just doing text completion, there is now text interaction. And that led us into this concept around the agent. So that means that, can I get a generative model to write code for me to be able to wire two web services together to go access my data, add an entry to my calendar, book my flight for me, do a number of different actions on my behalf, is easier said than done. Because if you're going to create some kind of agentic framework, you need to make sure that it doesn't stray off the path. You want to make sure that you understand what all the actions are that it can and cannot take, especially the things that it's definitely not allowed to do, because you might get it to perform actions that are illegal or that can cause enormous pain for whoever the interested party is working with it. And that means that we're on this journey, this what's called AGI, the artificial general intelligence, using generative models. It just means that what we're trying to do now is not figure out how much memory we need for an agent to remember what it's done, how much attention does it have to apply in the context of determining a certain outcome. And a big part of this is to not just focus on system one, but also system two thinking. That means that, can it interpret and cannot take an action based on an interpretation to perform a series of outcomes reliably. And this is where I think everybody are trying to play. And we have got some examples we'll get to later when we show you a demo of what we're doing. Just think about what that entails. If you have to look at where people are spending money in this space, we're seeing that in something like advanced manufacturing or energy technology, where there's well-defined understanding of processes and they're very difficult to navigate, it's very different than telecommunications, financial services, or media and those companies, where you know that there are thousands of processes and steps being executed daily that can be changed and can be made more streamlined, as long as it sticks within a certain guardrail, or it's going to stick with the rules that you know that you've defined up front. We definitely see that some industries are more interested in this. And the other thing is that you want to understand how much of an employee or a person working in a company's time is exposed to using some kind of generative tool. Generative meaning that it can complete sentences, it can have conversations about a particular specialized field. And we're seeing that in the context of financial services, telecommunications, in the media world, maybe even all the way into the insurance-related world in financial services. There's an enormous interest in trying to figure out how you can use these tools a lot better. What makes it tough is the fact that you need certain bits of groundwork done. And that means that the groundwork that has been done in the last few years with people running smaller experiments and various type of kind of interfaces that normally are part of getting a product like this or a platform like this deployed, means that some parts of a business is definitely more important to focus on than others. And the parts that are being focused on are the areas of the business where there are enormous amount of complexity in the communication infrastructure, but it's not necessarily related to being highly accurate and precise. A risk score or a credit score for somebody, or if I'm going to determine if somebody is going to get a loan or not, I cannot rely on a model where the output cannot be reproduced reliably, consistently, and can be audited and explained to people who's going to ask questions about it. So that's why you see that there is this focus in the context of marketing and sales, product R&D, product interactions. But even in this space, we are seeing that companies are battling with it. So that means we see an enormous amount of companies focus on how to do this, but some of them are still having issues getting it implemented. So how do we get through all of this? Here's some background to consider. The first thing is how you think about the way in which you engage eventually with whatever you are going to be designing in the context of your AI journey, what you're designing it for. And we are looking at it typically within these various pillars. If we think of the individual, so that means you or me, or somebody sitting out there engaging with a digital channel over glass, or voice speaking to some kind of voice agent, or we have a physical human face-to-face interaction. We want to get advice, and we want to get something that is highly specific to the situation that you are in, because you might have exposed some of the things that you require in the conversation. So you might ask for something that is related to, I want to know more about this product. I want you to explain the options to me. And yes, I'm now ready to take it up. Once I've taken it up, what do I get? So that journey that you go through is highly individualistic. The collective is to understand how groups and segments and people behave across different age brackets or income. Historically, it was easy to block everybody into a certain demographic, like you're a Gen, a Gen Z, or you're an X, or whatever that might be. But that's not really practical in the new world. You want to find new ways of doing that. And that means once you've created this, how do I impact an entire society? So that means a broader target market with what I've been able to implement, if I get it implemented successfully. For today's conversation, what we're trying to do is just to give you a glimpse of what this broader field looks like. And obviously, you will find that as you do searching, there are just so many options available to you that you just don't know where to go. So what we're going to be looking at is two primary dimensions. One is, if you're going to focus on something that's business as usual, so that means that the things that I'm doing today, day by day, and I execute it step by step. Again, transformational meaning that I'm making changes, driving some kind of new future, against an enterprise versus a customer focus. Enterprise in this example means internally focused. That means, can I get processes, practices, employees enabled to perform certain actions and get them to execute along a certain journey? There are many options available, but for our conversation today, the idea was to look at the customer-facing area first. In a future webinar or feedback, we can then talk about what sits in the context of an internal part of a business and how you would deal with efficiency. So where we probably need to focus is on how we deal with continuous engagement, conversational nuances, and the noise in the conversations when people are trying to find options that are relevant to them. And how do you create a guardrail and the rules and all the areas that are needed to make sure that there are no mistakes in the engagement? For those who have spoken to us before, might have seen this particular representation from time to time. On the left of the center line, it's focusing on what the cases would look like if it's a customer that you've never signed up or the customer that's engaging with you. On the right of the center line is when a customer has purchased something from you or they've engaged with your digital service, and you're trying to get them to act on whatever they purchase from you continuously, all the way through to the point where they've been with you for many years. You want to maintain a very sound relationship. What do you need to do? You'll see later when we show some of the examples that they will fall within these categories. The thing that we sometimes forget is that you need to have various processes and approaches when you think about how actions get taken inside a business in order to be able to deliver on anything that's got to do with a predictive related capability. If you deal with static models, we see the world in three primary pillars in the context of how predictive capabilities in the AI world are playing out. Static models is when I'm relying on historical data. I'm relying on classical machine learning and algorithms to make sure that it's explainable and that I can package it in a way that is completely repeatable again and again and again to be able to get to a certain score. Dynamic models is when I want to get models to converge in real time when there are high degrees of interaction, high degrees of novelty, high degrees of volatility, and I want to be able to figure out if I can capture the essence of that volatility in real time rather than having to deal with the training of models over time. And then we have the generative world. It's a special class of treatment. Static models, we take data, create feeder stores, train models, configure for deployment, we put it into production, we track the production monitoring, we start the cycle again, and you never stop. And every one of our hundreds of cases in production, we found that the parts of the business that generate the most revenue, 90% of the revenue comes from static models that perform highly reliable actions again and again. If you turn it off and you see the difference in performance, you can figure out where the real benefits lie. We know that static models and the practice of how to do this, starting with an hypothesis, implementing your models and being able to get some kind of output, is an ongoing interest. But the dynamic models reduce the complexity and it makes it easier for you to deploy it because you do not need the complex feature engineering, the complex historical data review. What you need is a clear understanding of the rate of learning and how a customer engage with you, taking that capability and making sure that that gets bolted into the final deployment of how you do things. The differences in the dynamic models versus the static models is that you have a far more dynamic ability to tweak things like you typically see with a lot of the generative models. In the generative world, this is a kind of rendition of an evolution, but there are various approaches that you can follow. The one approach, and the one that we see with the first three pillars within this depiction, really tries to understand that there's a basic understanding of my data. I can get a model to produce an output that is consistent and reliable. Can I get an agent to perform some kind of thinking? So that means that reasoning, and take that reasoning and then have an adversarial model checking that the reasoning is actually correct before it finalizes the exercise that whatever it's involved in, all the way to the point where they provide you with a response. So you might have seen with GPT-4o1, or if you've seen with the new Anthropic models or the new Gemini or all of the new models, all have the same capability. DeepSeek R3 or any one of the new capabilities are the same. And that means that taking it through a series of steps, working out those steps behind the scenes, and then producing an output. How can you repeat that in your own business? You need an exercise like this to be done. You need to understand the business need, to understand the use case, and know where it's going to have an impact. You then need to drive some continuous prototyping and configuration where you can get to understand the case that you're working on and the evidential data that might end up in a feature store that is, in this context, like a vector store, or you might have to decide on a certain kind of model because most of the models have been trained commercially to solve very specific problems, and then go through all the various steps, depending on what you want to configure, to the point where there's what's called a user interface test to make sure that a human can get the response that they need. That means that in the old days, the testing was focused on, based on a certain calculation, can I get a reliable output? Now, can I get a certain kind of narrative in return based on a user input? So we find that in some companies have got more than 300-400 different questions that typically get asked that they run through their tests. And once that's done, you then configure your deployment and you then put it into production. And once it's in production, your learning continues. In static models, the learning is frozen. It goes through an entire recycle. In generative models, you have reinforcement learning through human feedback, meaning that every time a human provides a response, you want to be able to act on it and produce something new at the end of the cycle. So for one of the cases today, let's just talk through what a typical agent would look like and what the actions are that it would need to perform if you had to go through the various steps. It's kind of an agentic AI use case typically. If it's purely a linguistic interface, that means it has to be linguistically useful, and that means in a certain language, I want it to describe all the elements of what I want the exercise to be by the time it provides me a result. The point is you can provide it with a number of different explanations that deal with the verbs, the nouns, the adjectives. The verbs are the work, the nouns are the outputs, the adjectives is how well you want it done, or what the impact would be. Then you would want the AGI or some kind of engine to unpack that and let the reasoning framework execute each of those steps, step by step, to the point where it provides you with an answer. Where in this example, the challenge is that if a customer would have to, let's say they go to your website, they say, I want to open up an account. I want to be able to get a loan. I want the loan to be approved. I want to then get a credit card. Then I want to add money to my savings account. Can you please get it all done for me in a single instance? We know that the real world often doesn't work like that. So you want to be able to provide guardrails and rules around obtaining information from the customer plus providing feedback. But this is the dream of what many of the agentic AI use cases have in the context of its background reasoning. In our previous meetup, we spoke about this, how agents drive automation. And the big part of this is that you can kick off a series of workflow steps that are automated either through a human interaction saying something, or you can kick it off through some kind of time-based or an event-based engine that will start a series of actions. If those actions are hardwired, you've got control over it. Or if some of them are hardwired and some are not, you got some control over it. This broader dream that we're going to be able to automate everything that happens every single day, all the time, without having anything pre-documented in very well-defined graphs. And at the moment, that's not really the case. You'll find that all the frameworks we'll talk about later deal with the various patterns of how you will get to a point where you get an agent output that is reliable. There are a number of patterns available. The reflection pattern and the like is the ability to get feedback, review it, and provide feedback back to the engine to say that, yes, I am getting to a result, and decide what the breakout point will be. The tool use pattern is the one that is probably the most implemented today. So that means that you've got a catalog of tools. The tools could be add an entry to my calendar, generate an email, write a message to my WhatsApp channel, or write a record to a database, write a file to the operating system, whatever the actions would be. You have got a catalog of these tools. And then what you do is you get your agent-based framework to execute on the tools, and it will select the appropriate tool for the job to be done So that means that you need some kind of pattern to solve that for you. The planning pattern is when you need to take a complex prompt, break it up into pieces, figure out what needs to be done one after the other, and then go and schedule what needs to be done. So you often will see that the planning pattern will use the tool-based pattern. The tool-based pattern will figure out if the correct tool is used. It will then go and reflect on the fact that it picked the correct tool and then get done with it needs to get done. The multi-agent pattern is you always have alternative options. You might have 1, 2, 3, 10 different options to perform the same action. So how can you get it to perform the right kind of reflection using the right kind of tool so that the planning pattern can execute on the actions that it needs to take? So we just see that a number of these patterns are emerging, and they are really practical for you to be able to implement those in some kind of end-to-end execution environment. So what I want to go into next is just to give you a glimpse of some of the industry architectures that we've looked at and that we've seen. And actually, this is a very, very small subset of what the broader availability is in the space. For those who follow Agentic frameworks will know that there are hundreds of these available out there, but we can tackle a couple of those. The first thing is, let's just get a calibration on what the core component is, or what the core components are of an agentic framework. An agent that's going to perform work for you will get a request from a user. So that means the request could either be partially pre-prepared or to become straight from a chat environment. It needs to determine, in this context, there are 3 different intents. The intent is either perception, cognition, and action. So the perception is, can I figure out if whatever this agent is about to do, that it's got to do with something where I deal with visual cameras, interfaces, text or audio? Do I need to have access to other sensors? If you have, let's say, a 5G or some other kind of interface or an IoT interface, do I need to go pick up results from these instruments to take an action? And that means the ability to figure out the perception of what the actions are that need to be performed to get this agent to provide a proper result back. But I also need cognition. So that means that I need to understand how much of what are being sent should I remember and should I not remember. So you might know that when you've done prompts with models, you would say to it, please try this. The only difference with an agent is that you need to create a systems prompt and the rules around how you're going to use some kind of generative capability to force it to remember certain capabilities, and also then to go fetch knowledge from a store that might have been indexed to a vector store or some persistent capability, so that the decisioning engine that's going to make the decision based on the action to be taken can be taken reliably. And that is by far the number one priority. Can I get the decision repeatedly to perform the same action over and over again? And later I'll show you the Ecogentic environment, the big focus for us to make sure that we rather want to constrain the world than open the world up if it's in a regulated or some kind of environment where it can create a risk. That means the action that is performed at the end needs to perform an action that's related to something in the real world or some physical action. That could be an API or something, some kind of technological interface. So that means at the core of the agent, on a one end, you use tools, and tools could be your channel interfaces, your interactions with your WhatsApp channels or your calendar or whatever that might be. And on the other end, you need some kind of planning. You need to give it a journey, a workflow, a series of steps, and it needs to remember what it is busy working on. So if it is working on a particular customer set of actions, it needs to remember who the customer is, what is related to it. So it needs to have some kind of memory to be able to deal with that, either long or short-term memory, because in the short term, I might want to override some of the things that were done in the context of the immediate conversation. So the basis of the modern advanced architecture. This is a rendition from Archivate that I think is a great rendition. It's pretty much how I think the industry sees a lot of this related input. And that means that on the one end, you have an input layer. Input layer is going to deal with either offline or online data sets. Offline data sets could be logs and data access and anything that has already been stored. Online could mean that it's a direct interaction with somebody, let's say on a chat, or somebody coming through an app and purchasing a data bundle, or applying for something, or transferring money, or whatever the action is that they're performing in real time. Then you need some kind of orchestration layer. The orchestration layer is where most of the thinking normally goes into, because if you are non-regulated and it's mostly for entertainment, you can just let the agent loose. You can let it have conversations. The participant can ask about the weather or about travel, and it will attempt to give answers as long as it's not going to recommend a certain price or something that affects the business, so it can go on with its actions the way it normally would. But if you're in a regulated world, you don't have that luxury. You need to know exactly what is not allowed as well as what is allowed. To document every possible capability is almost impossible. So you need a framework that can help you so that when you do multi-agent coordination and conversations, you want to guide it down a certain route to make sure that it gets it. That means your AI agents that you then use must be reliable. You want to be able to select multi-models. And as we know, that multi-model implementations is really the way that you're going to do it. So if you use Bedrock and AWS, or you use Microsoft, or you use Google's LLM interfaces, all of those support multiple models, and you might end up running one of these models on your own premises. That means you need a framework that can bring these pieces together without having to deal with the complexities of what you need to then handle by the time you produce an output layer, where the output result is either an offer, a recommender, it's a graph, it's some kind of output that you know that you can wire into many other places depending on what the scenario is that you want to implement. Now, Insight Partners published this note on the no-code versus low-code agents, and we are seeing that if you had to code an entire agent-based framework from the ground up today, you know that within a month, 2 months, 6 months, a year from now, you would have to recode it and recode it and recode it, because the frameworks that are underneath the base capabilities are evolving so quickly. The amount of work is just enormous for you to get it done. So the idea is at Ecosystem, we, with the Ecogentic Framework, have been able to capture an abstraction layer that deals with the metadata of what a flow would need to be. And that flow can be implemented in various frameworks. Our framework plus, you can bolt in a Copilot or a LangGraph or some other framework without having to deal with the complexities that you normally would. That mixture of architectures is an enormous focus for most of the frameworks that are in existence today, especially for the ones that are economically viable for a company to deal with an initial implementation, so that they can capture their knowledge in a particular area, apply that knowledge over and over again at a license that normally sits in the back of this implementation. That means that a typical reference architecture might look like this. This is Menlo Ventures. That's half the venture world, and there are a couple of other venture firms that I haven't included yet for the sake of brevity. But the way that the venture world is funding the tail end of the LLM world into the agentic world, because LLMs, as you know, and generative models and language or multimodal models are largely commoditized. So that means you should buy it at 0.01 US cents per million tokens, or whatever the price is, depending on if you run on Grok or one of the other architectural frameworks. The point is that the model is not where the value lies. The value lies in your ability to bring that concept into the organization to solve a problem that is real, that is immediate, that is going to affect the customer, that's going to affect an employee, that's going to affect a decision. And that means that you need multiple moving parts to come together to make that happen. For you to be able to have the ethics, the rule book, the data access, the way in which you're going to deal with searching of data that might have been produced through email and other capabilities, or agent actions that are going to be orchestrated to execute certain steps, or maybe even using a generative agent to have a conversation with the user so you can determine an intent to take an action on that. You need to bring all of these elements together to make any of the modern architectures work, especially the ones that are more advanced. Now, LangChain has been around for a while. We are big fans. I like the community. I like what they've achieved. And for those who are interested, there are amazing Python examples for you to go on and play with to produce your own agent framework. It's really worth doing it just to get an understanding of what all the pieces are. For those who are interested, we can share it with you. We've got many different labs that we've created internally now with clients and partners to show how a lot of these concepts work. But the basis is that if I'm an app developer working on steps to get to a certain outcome, and I know that I've got data access where the data is in most cases in an enterprise setting, accurate, precise, and exact. So if I want to know that a customer balance is over a certain value, or I want to know if the customer's credit score is of a certain score, you definitely do not want to have a generative or some model that's going to make up scores other than the numbers that were produced based on an algorithm that has been audited and that you know that it can be checked consistently and reliably. So we see these two worlds coming together with various frameworks. And this is one of those frameworks that you want to have under the covers. In the context of the Ecogentic Framework, we've got a full LangChain, LangGraph implementation. You can access it, from the user interface abstractly. So as the platforms evolve, you'll be able to get those benefits over time. That means getting access to data that is potentially stored on a web for web scraping, JSON documents, email texts, whatever those might be. All of those must come into a store so you can access it consistently through some kind of journey on a front end. For those who know us, we are pretty big fans of the H2O stack, and Sri, who created this business with his team, have been doing an amazing job, especially in the context of its Java and its H2O3 stack. So we still have many components of the H2O environments in our core. They've created an LLM studio, and according to their latest results, they believe they have the most reliable agentic framework that exists today. So they've been able to get something like 70 or plus %, responses correct in the context of the latest data tests in the context of the LLM, and especially in the context of the AGI world, compared to many, many other, but including OpenAI, that is only sitting at something like 30 or 40%. So we know that everybody, and especially in the context of the core frameworks, are busy working on these capabilities. And if you are in an enterprise or you are in the business and you have to go figure out every one of these moving parts and trying to get them all to work together, that is an enormous job. And that's what the Ecogentic journey is that we're going to be exploring a little bit later on. Now, Microsoft, for those who have followed their public feedback and any of the announcements that they've done, including the fight that's happening at the moment between Microsoft and Salesforce, that there's an enormous butting of heads playing out in the market, is claiming that the future of coding, the future of using a spreadsheet, the future of using any kind of PowerPoint or any one of those classical tools are all under threat, because there will be a point at which everything is going to happen through conversations. You'll be able to ask it a question, it does the work for you, and you move on to the next step. So that means that the whole Copilot framework is something that most companies today who run any kind of Microsoft components or run the component suite would have access to inside an enterprise. There are some public versions, but most of it will happen in a private setting so that you get full control of what happens inside your business. The Amazon Bedrock obviously is a big focus for everybody as well. For those who are in the AWS stack, there are these three major fights playing out in the market, and Oracle also now entering it as a fourth player. So that means you've got the AWS and the Microsoft with Azure and the Google with their GCP and their kind of AI stacks all competing. So we believe that as an enterprise, you want to have the right to select the best options for you, depending on the pricing and the stability and the capabilities and the security frameworks, but they are commoditized. That's not where the work gets done. The work gets done by the time you and your business want to get some kind of implementation that's going to do some work for you. So if you use SageMaker or Azure Machine Learning, that's kind of irrelevant in the bigger scheme of things, because you want to be able to execute on a particular business requirement, get a particular business solution that is way beyond just having a generic capability that you have to build from scratch over and over again. Okay, so let's talk about the Ecogentic construct. You might have seen in our last few meetups and our previous webinars that we've done, we have discussed the concept quite frequently, but the basis of it is that there is a broader understanding of how we know that work can be automated, and you want work to be automated reliably. It's overlapping into RPAs, robotic process automation. It's overlapping into the digital engagement, digital world. It's overlapping into the prediction world. That means that if you can think of a Venn diagram with all the different dimensions coming together, as an enterprise or as a person who wants to implement some kind of solution, you're now sitting with these thousands of options as to how to get a certain outcome executed reliably. So one of the things that you're going to have to think about is that you need to have some kind of agentic ecosystem or agentic framework that where you're going to be able to place from whoever the supplier would be, or maybe even your own team, because you're definitely going to have people inside your business or even your own organization creating highly unique agents that are specifically performing certain tasks. And you want to be able to put them into a registry and make them accessible so that they can be orchestrated to perform work over time. What it is doing is putting a lot of pressure. Let's say that you want to have access to a data source. The way that you access the data needs to be within the security framework of the business, within the framework of whatever that particular product or service is. If it's for a particular customer, am I going to be able to guarantee that if I achieve for that customer some result that it is specific for a certain person, all the way through to the point where if I want to have this linguistic conversation, that I don't get the bot or some kind of user interaction to make up anything that's to do with social engineering or something else that's going to affect my business negatively. So you need some kind of mesh environment or ecosystem to define that will create the rules for how you control your agents in your business. The one that many of you have seen over time is an ecosystem example. There's the spend personality that we've implemented in the context of 2 layers of framework. And maybe to explain this, in our previous meetup, I showed this, but I didn't get into the detail. On the front end, you can use, like in this example, OpenAI, or you can use Anthropic with Claude or their front-end chat, or you can use Google with Gemini, or you can use H2O, or you can use Hugging Face, or any one of the chat front ends. And the thing is that everybody now have got access to some kind of user conversational interface, and that's not really where the value is. The value is what it gains access to, and if it can reliably execute on a series of steps to get to a point where it gets to an outcome, like I mentioned earlier. So in this example, if I ask it about customer 580 spend personality, I don't want it to hallucinate about what a personality is, what a spend is, who the customer is. If it can't find a customer, it should come back immediately and say to me, I cannot find it. What do you expect me to do? And that means that it needs to have a way, this is set up, as you see in the example, to stop because of human intervention, but this could have been automated entirely. You could run a daily job where, let's say, the agent workflow needs to go figure out who the customers are that you should definitely be talking to tomorrow, figuring out their personality spend scores, work out what communication channel you should use, work out what messaging you should apply for them, figure out if they're going to leave the business or not, tie it together, and then generate a series of emails that will send to some kind of employee that can then allow whatever this process that normally would follow to have a conversation with the customers. So that just means that these abilities to do code generation in line and to bring multiple agent frameworks together is something that we definitely see in the future. In our context, the Ecogentic Framework runs behind this as an entire sequence of activity. And the front end, the conversational piece, could have been an Excel spreadsheet, or in this case, an OpenAI kind of front end where you can have a conversation. If you do it within a Microsoft Copilot environment, you can just go and configure a Copilot. We publish these Copilot journeys for you. You can also use, a number of other technologies that are available, like Infobip or any tools that deal with journeys generically on the front end. But the thing is that you still need a series of sequences that can bring human in the loop reliably. And later on, I'll show you how that gets done. Like in this example, this particular case is where I'm having a conversation with a Copilot, and the Copilot needs to pick up what the spend personality is, what the details are of my personality. And if it doesn't know it, it needs to go through maybe a survey to get some kind of indicative score, but it needs to focus on staying within the guardrail. So when it calls the backend, the set of rules that are defined within that backend, the Ecogentic framework, must never hallucinate, must never stray from the core of what its purpose is in the context of the job that needs to be done in the moment. So like in this example, if I go through, let's say, a survey and eventually it produces a result that gives me a score, I want that to be done in the particular front-end journey engine that I'm using, whoever is the front-end to whatever that agent-based framework is. So you want to separate the various components in some kind of way that makes it reliable. So we see the agent drive automation, the fact that you start maybe with a chat, you have got a journey like I explained earlier, you might bring a voice, you might bring a WhatsApp and various other parts to it. And eventually, by the time you decide on your design, you will have to have some kind of very clearly defined understanding of the one end, something being linguistically useful, linguistically generic, and on the other end, something being accurate, precise, retrieving exactly the value that I need. And you want your agent framework to straddle these various different pillars. You want to be able to have some kind of agentic framework where you can just wire it together and get all of that done for you. So what we put together essentially is a framework that bring all these parts together. So you'll see that the ecosystem server, the backend, our access to generic LLMs and so on, all is seen in the context of models as a service. An OpenAI's GPT-4o1 or a DeepSeek or any one of those kind of related models that have now become platforms, it is just not practical. But you really want to make sure that the one that you use is the most useful for the job that has to be done, for the job at hand. And that is what we really think is going to be the key part of the enterprise spectrum. And that means that have this ability to bring these parts together so that if you have some kind of entry point and you start your journey by saying, I want to perform this action, or this is the job that I need to get done, or I want an offer on a particular product, you wanted to stay within those specific rules. So by the time the execution gets done, the access to real-time recommenders and real-time environments, you want to be able to get the next action or the message or even certain conditions to be returned from something that you know that is auditable, that you can review and check to make sure that it's done exactly what it is expected to do. In our world, if you had to think of what we refer to as hyper-personalized offers, let's say that you want to make something that is just for you or just for me in the context of some kind of interaction. I need some kind of recommender, depending on what it is. And this is, I think, the departure point from the historical world of generic recommenders and a new world of AI-enabled recommenders, is that if I've got reliable history and you are a person that is incredibly ritualistic in why you buy products the same way as everybody in your society, then you can probably use some kind of recommender that you get from your primary cloud provider or some kind of generic framework. But we know now that the Netflixes, the Spotifys, or the companies who have been able to capture our imagination with the recommendations that they create for us, even though they are wrong from time to time, make sure that it's not just about the concept of reliable history. They have an ability to deal with dynamic models. So that means, can I capture the dynamic changing behaviors of a human as they engage with an environment and take those scores in relation to the models that I've trained on a society, and then create multimodal models that can be wired into my agentic framework, so that my agentic tools are not expected to hallucinate, to make up any concept. Its job is to orchestrate work. The job of an algorithm attempting to figure out what a customer is all about, what kind of interactions are specific to them, what the personalized recommenders are for them. It knows exactly how it is going to be able to do its particular set of actions that you can audit, you can track it, you can tweak its parameters that have got nothing to do with a linguistic problem. And I think that we see a lot of people confusing these two, thinking that they just use one to replace the other. So in our case, we work on the Ecogentic graph, and the Ecogentic graph basically is a directed graph to get you through both the structured and guided part of a journey, as well as through a conversational part of the journey. If somebody is going to ask you what your age is, you know it's fairly factual. You know your date of birth. You probably have the number of how many years you've been alive until your next birthday, and you'll be able to give that answer immediately. You do not want somebody to make an assumption about that. Assumptions will come later on when that number gets plugged into where it gets used, but not the point at which I extract the evidence of what it is that I've captured about you. If I want to know, like in our example, we've got a number of algorithms, but let's look at the spend personality or the money personality. Let's say I take the spend personality, and I want to know that you spend money on essential spending, you're an intentional spender, there's a score that gets given to you on a spectrum. I want the algorithm to provide me a reliable score that I can then include into a generative capability to then make a decision on it the way that a human would have made a decision on it. So that just means that the Ecogentic graph separates these two capabilities. On the one end, go and fetch, go and score, go and do things that I can explain. On the other end, allow conversations, allow interactions that will then go do work all the way to the point where I achieve the final step, or in this case, you always have some kind of closing point to say that, yes, I'm done. I want to restart again, or I'm done and I want to move on until I speak to you again in a day, a month, a year from now. The point is that you have some kind of beginning and an end with a number of steps in between that you want to be able to control fairly reliably. So for today's example, what I thought we'll do, and for the sake of time, I'm just going to spend maybe 5-7 minutes or so on the concept, is to talk to you about what we call the intelligent sales module. So in our world, we have what we call modules. Modules basically are pre-configured use cases where we have found companies having some kind of request where they solve the same kind of problem over and over again. We've been able to package them rather than creating separate products for each one. We'll shop it. In our case, can you take the assets of the data that's needed, the algorithms that are implemented, the way that you want to deal with the Ecogentic interface, or if they are static or dynamic or generative models in a full stack, how do I bring all of those pieces together so that I can then deploy it to somebody and put it into production by applying their own data only, if they want to do it like that. Once you've done it, step one, you can then influence it by deciding how you want the algorithm to change its behavior and then implement it in some other way. So today we're going to talk a little bit about intelligent sales. So in the intelligent sales world, if you had to do it in, let's say, InfoBurp or one of these kind of platforms, you would have had to build all of this from scratch. You would have to go and create your own intent engine. You would have to create contextual rules. You would have to hardwire everything, and it makes it entirely custom just for that particular solution. So we don't recommend that as a good way of doing it. If you're going to do it in your Copilot, you would have to start from the beginning to the end, and you would have to document all the series of actions and then go and hardwire it for that particular implementation. Or what you want to be able to do is use something like what we have to offer, an Ecogentic journey, where the journey will take various components, various types of nodes, bring them up into a very, or basically bring them together in a very succinct journey where you can start with one beginning point to say, hey, how are you? Or hello, all the way through to determining what my interests are, to the point where it then gives me some kind of answer at the end. Okay, so what I thought I'll do, I'm going to go out of that, and we're going to switch our context just for a moment. So this is the ecosystem workbench. Idea today is not to work through the workbench or looking at its capabilities, but you'll see that we've got a full project management, and there's a way in which you can manage your data, static models, the way in which you can manage all of your generative based models, a way in which you can manage your dynamic models, and all of these capabilities come together in one. So there are the static models, the dynamic models, and the generative models. All of those are needed to the point where you can test it through some kind of API, or maybe even run a simulation if you want to reproduce a series of actions. Check the score to make sure that it's actually giving you the correct output that you want to achieve at the end. So what we're going to talk about today is kind of a telco journey. And in this telco journey, we have to look at the data sets that are available. So behind the scenes, there's a like a customer data set, and there's some chat configuration, and everything have been pre-configured. There are also a number of dynamic recommenders. It needs to figure out dynamically if the conversation is about phones, data bundles, OTT, streaming services, or the like. It needs to get the deployment to figure that out. In our world, the deployment is called permanently in production. Once the clusters have been spun up to run those recommenders with all of its rules around horizontal scaling, you push the configurations into production. There's a log produced in the backend, or it's run through your team building a pipeline to get into production, and it gets all of the work done behind the scenes. Now, if we look at the agentic scenario, and I'm going to pick one example, I'm going to give it a user that's already valid, and let's just reset it. So that means that this particular journey is now going to start with a valid user. And what you will notice as I work through it, I'm going to keep it fairly zoomed out. You'll be able to see how the nodes get highlighted. Some of these nodes are very specific around what it needs to do, including its guardrail. Some of the nodes are configured in a way that they just are for conversational purposes. So let's not go through the detail of the nodes, but I'm going to just ask it. Let's start with a typical chat might start. I'm going to say, hello, John, because it knows that might have been a customer ID. This customer ID could have been validated through an app, call center, or I was on some kind of web interface, or I was somewhere where it got to understand who I am as a person, and it then finds out the details about me. And if you look carefully, you'll see that there's an orange line around this particular node, because I wanted to extract the details of John, because I know the customer has been identified. It must go do the work for me and return it for me. I can then ask it. Now what it needs to do is detect the intent, get the guardrail to figure out if it's actually doing the work that it needs to do. So what it's done, it started at the top, went through nodes, and ended up in this node over here. That node, if I turn on its properties, you'll see that node is a text node that now provides a result back, and it came from a recommender node that I have determined the intent of the person. So you've got continuous intent detection to make sure that you can guide the conversation so that it doesn't break away from what the core rules are. In that case, the dynamic recommender would have passed it on to this message. If I then select an item and I say, yes, please give me one, you see now it's gone to this node. I want the model to converge and to add it behind the scenes to do certain bits of work for me. So now it's added it to my, and if I say to it, yes, let me get some data bundle recommendation. And just to get through the end of this exercise, I'll pick one that I like. And through this entire journey, you'll see that it's guiding me all the way through, depending on where I want it to go. When it gets to the end, let's just say checkout. Okay, so now it means that I've concluded the purchase. All of this work and how that gets done is then recorded in the ecosystem dashboard, right? So if we go back here and look at the particular campaign that was set at, that was the telco sales, and I apply it, it will give me all the actions that we've just performed now and explain to me what the dimensions are of the actions. I understand the logs of how those were executed, and that means the work that was done by the agent over time. I also understand all the messages that took place between the agent and the front end to the point where it got its final work done. So that means the entire backbone, the logging engine, and everything that goes with it is predefined. Is I have all of the classical logging of the ecosystem environment predefined because it recommended certain items to me, presented it to me with certain scores. So that means the classical dashboarding of the way that the agents that perform the work are being tracked, are being monitored, so that you can configure the journey reliably. Is all that work is done for you behind the scenes, to the point where I eventually say to it, well, you know, I'm busy exiting, and it will tell you that there's my cart and I'm done. And that's the second last message. So that means you can decide where you want the journey to go, how you control it, where you take the final steps, all the way to concluding whatever actions you need to take at the end. So maybe just then to wrap up for today, the idea was to take you through a quick view of agent architectures. It's a very short time to cover many of them in detail. We will run some in the future to show you how you can code these things yourself from the ground up. We will show you copilots and various other ways to build it, or you can just use the Ecogentic Framework. It can do many parts of this work for you automatically. So Jess, I think that is really it from me today from a Ecogentic point of view, just so that we can give our audience an overview of what the concepts are.
Fantastic, Jay. Thank you so much. Really appreciate it. We've got a couple of clap emojis.
I love clap and thumbs up, some of my favorites.
Excellent, everyone. Thank you so much. We hope you have a great afternoon, and we'll catch you next time.